All right, good morning. Well, thanks for coming here. We're going to talk about a dozen cool things we can do with the different JVM languages. But before we get started, let's talk a little bit about why should we really care about using multiple different languages. Well, I consider programming languages to be like vehicles. We use bicycles, we use cars, we use airplanes. And on a given day, you probably use multiple of those depending on where you want to go. Well, to me, these vehicles give us different conveniences and different capabilities and power. And one of the really awesome things about being on the JVM is, while we can benefit from Java, we can also leverage the power and capability of all these different languages for what they provide. So what I want to do here is to share with you some excitement I have about some of these capabilities in different languages and how we can leverage them on the JVM. So as a result, when you're developing your enterprise applications, not only can you write code in Java, but you can also leverage the power of these languages as well fairly well, where it makes sense, much like how we switch between different vehicles on a given day. So let's talk about a few different things we can do. I'll talk about these things to various degree of depth, depending on how much we can focus on in the time we have with us on our hand. So let's talk about accessing files. Now, those of us who have programmed in Java for a while remember how really tedious this can really become. And when you start writing it, you start opening your file stream and you're trying to read a file reader. And then very quickly you get dragged into all this try and catch block. I'm sure there are days you pause and ask the question, what was it trying to do again? Because the code becomes so complex, we tend to forget that along the way. Well, how do we really read a file? Let's take a look at a quick example here. I'm a big fan of some really interesting languages on the JVM. Some of my favorites are like languages like Groovy, Scala, Kotlin, JRuby, Clojure. I would say these are some of the most favorite languages on the JVM, other than Java, that are really popular as well. Well, here I'm looking at Groovy. I'm going to start with a little print line, no ceremony, as you can see right there, and I'm going to say new file. And if you wonder what this file really is, it's nothing but java.io.file. It's the same exact file object that we use in Java, the JDK, but I'm going to say over here, this is going to be sample.groovy. How about simply reading the file itself that we have at our hand? And I'm going to just ask for the text property out of the file, and that's an example of a piece of code that's reading the file and then displaying the content of the file. It's that trivial to be able to read a content of a file and get the display. Now, obviously, in this case, if you want to read a file and process it, we don't have to work really hard, as you can see in this case. Well, not only can Groovy do this, here's an example from Scala. So I can say, for example, scala.io.source, and I can say from file right in there. And in this case, of course, I'm going to ask for the sample.scala. Well, Scala returns an iterator, so I'm going to ask it to do a make string to really combine all of those values together. And that's an example from Scala to really read the file content and then display it. Of course, you can read any file you want to. Now, clearly, when you look at this, you may wonder what happens if the file doesn't exist. Well, it turns out on the JVM, the only language that is insisting on checked exception is Java. And a lot of times, programmers tend to forget this. Checked exception is not a JVM thing. It's actually a Java compiler that's insisting on checked exceptions. Most of the other languages simply don't care about it. And the reason is, what happens in Java when it insists that you have to handle the try-catch? Well, programmers often put empty catch blocks around the code. That's programmers telling Java to know who is really in power here, right? So you can never force a programmer to do the right things. You just have to motivate them. Well, these languages treat programmers as adults and give them an opportunity to do what is really right, and they can make the decision. So you have to still handle exceptions, but you don't have to get dragged into it at the very first effort of prototyping. Well, the next thing I want to show you here is interacting with external processes. Now, this reminds me of an experience I had a few years ago. I had a piece of code that had to do some operation when a particular file was pushed into the version control. And I had written this code a few years ago, and I was looking at this code and I realized this code was not really that big. It was about 150 lines of code. But to my surprise, of the 150 lines of code, nearly 100 lines of code was dealing with starting an external process. And programmers will secretly tell you they have much more pleasure in rewriting code than reusing code. And I decided to rewrite this code on that particular day. And I decided to use Groovy for that particular purpose. And to my surprise, that about 100 lines of code came down to 5 or 6 lines of code. But nevertheless, how do you really start an external process? Let's take a quick example here just to entertain that thought here. Now, clearly here, I'm going to start with print here in Groovy, and I'm going to say git help, and as you can see, that's just a string and nothing really exciting at all. But the beauty is Groovy has a set of APIs that are injected into the JDK classes. So in this case, of course, it's a string class, and if you even wonder what this is, it is nothing but the Java lang string class. That's what you're really dealing with. But Groovy decides to take this particular class, and you can do an execute on that particular string, if you will, and ask the text output of it. So what this really provides for us is, that is the output from git help, as you can see right there, but you can turn a string into an executable process. Again, if you're curious to know what it's really doing, if you look at the output of execute, it is nothing but the process object that you get. So essentially what Groovy did was to add an execute method to string, so you can turn any string, hopefully sensible string, with a command in it into a Unix process or Windows process, whatever that could be, depending on the operating system. And then, of course, you can simply execute it and get the standard output using a temp, or you can use other properties to get standard error and so on. And of course, the 7 lines of code I mentioned was around this particular function to send the input and then get the output properly for executing this method, and that becomes really easy, as you can see. Well, of course, there are really good things in a lot of different languages, and to me, Java has come a very long way in recent years. So I want to share with you my excitement around one of my most favorite patterns in Java, which is called the execute around method pattern. So before we talk about this pattern, let's talk about a little example in Java. So let's say we have a class called resource, and the class resource has a constructor. Let's go ahead and say, just to entertain this idea here, let's say create for a minute. Let's also create another function resource, and we'll call it op1, and all this method is going to do is simply output, let's say, op1, and simply returns, let's say, return the current object itself. And similarly, I'm going to write a method called the op2 method, which is simply going to print op2 and return that particular object. Now, obviously, in this case, I'm going to call resource, and I say resource is equal to new resource. And then I'm going to say resource.op1, and I'm going to call resource.op2. Now imagine for a minute that this particular resource is using an external resource, maybe an open database connection, maybe a socket that's open, a remote service that it's talking to, or a file that's open. So anything that's not related to memory, let's say the resource is dealing with it. The question is, how do we get rid of that external resource? Well, here's the good news and the bad news. The good news is Java has automatic garbage collection. The bad news is Java has automatic garbage collection. Now, unfortunately, the garbage collector in Java is like the garbage collector in my neighborhood. Just because I put the trash out doesn't mean anything. It could be there for a long time. So the question is, what do we do about collecting this garbage? Well, unfortunately, though, over the years, the creators of JVM, while they've done several wonderful things, and the language several wonderful things, they did commit a few mistakes. And one of those mistakes is the method called the Finalized Method. Now, this method, unfortunately, let's say clean up, and unfortunately, though, the Finalized Method is going to be called when the garbage collector collects the garbage of this object, which is unpredictable. We don't know when that's going to happen. So if you put anything useful in the finalize, like cleaning up external resources, you have no clue when it would actually be called. And so if they ever wanted to rename finalize, they should call it bad idea, just to emphasize this shouldn't have been done in the first place. Now, clearly, the good news is finalize has been deprecated in Java 9. So moving forward, we shouldn't be using it. And if we do try to use it, we get a warning, as you can see, that it's deprecated. But the point really is, notice it did not bother to call it. Why not? The reason it not call it is because that there is a lot of memory, and the garbage collector did not find a reason to really collect garbage. Now, I think the creators of the the API have a really weird sense of humor. I'm sure there is somebody who created this sitting there and laughing at me, the programmer, because they created this genius method called system.gc. This is the funniest method ever because it does nothing. And so when you call it, it doesn't collect the garbage. In fact, if they ever want to rename this, they should call it hope, because that's what it really is. It represents a hope on the part of programmers that something would happen. So these are really terrible ideas. This is not going to happen. So the question is, what do we do? How do we really collect this garbage? Well, to answer that question, I'll share with you a little experience I had in the past. This actually happened for a client of mine. They called me and said, hey, Venkat, come on over, do a code review for us, and while you're reviewing the code, maybe you can help us find and fix a problem we've been having in production for a year already. And I was like, wow, you got a problem in production for a year. Can you tell me about it? And I asked the manager. And he said, go ask the programmers. And I went and asked the programmers, hey, there's a problem in your production. What is it? I want to help fix it. But nobody would tell me what the problem is, which kind of makes it a challenge to find a problem and fix it when nobody will tell you what it is. But finally, I was so thankful. I found one developer who nailed it. And he said, everything works fine most of the time. I said, that's awesome. Can you tell me when it doesn't work? He said, of course, it doesn't work between 7:15 and 9 in the morning. I said, oh my gosh, every day. He said, no, only Monday through Friday. Everything works fine on Saturday and Sunday. Well, that didn't really help me a whole lot at that point. I said, okay, thanks for that information. I will look into it. I started doing code review, and that's when I found out why the problem was there. Well, in the constructor, they were requesting a database connection. Well, there you know the problem already. And then in the finalized method, they were releasing the connection back to the pool. Now, clearly you know what the problem here is, because there's no guarantee the finalize is called, because there's a lot of memory, all these connections were being accumulated, never to be released. What do we do about it? Well, good news, and then a little bad news, and then a good news again. Well, let's talk about Java 7 for a minute. Java 7 has an automatic resource management as a feature. So what does automatic resource management do? The automatic resource management feature says, if you really want to garbage collect an object at appropriate time for external resources, well, you can use a try with resources. Now, as you can see in this particular example, the problem with this code is I could have written a close method right here, and I could have renamed the finalize as a close, as you can see right here. But the problem with this approach is twofold. One is a programmer may forget to call the close method. Secondly, if there was an exception between these two lines of code, the close is not going to be called, and that's going to be a problem as well. Well, to solve this problem, what you may do is put a try block right in there. And then, of course, if you put a try block, you may put a finally block right there. And then you could say that this object has to be garbage collected in that particular finalize, or the external resource has to be cleaned up in the finally block. Well, the good news here is that this will call the close method even if there was an exception. But the bad news here is threefold. One, the code is verbose. Second, you have to remember to use the try and finally, and you also have to remember to put the close as well. That increases the burden on us, the programmers. It's very error prone as well. So what can we do to remove that burden from our shoulders? Well, one thing we could do is to use the ARM, which is the automatic resource management technique. So you can take this particular object from here and you can drop it right within the try like that. So this is part of Java 7 and the future, so you can put that right in there. But of course, for us to be able to use this feature, you would have to go here and implement at this point, and you can say implements auto-closable, and auto-closable has just one method, which is the close method. Now, the benefit of using this approach is you don't have to really put the finally anymore, but when you run the code, you can see the cleanup happened automatically. And that is the benefit of using the ARM, or automatic resource management, or try with resources, is that you can clean up the object in a deterministic fashion by wrapping this in this boundary. Well, the good news is that the code is less verbose than it was a minute ago. You don't have to call the close. That's another benefit. But what about the bad news of this approach? I kind of wonder, what if the programmer forgets to call the try in the first place? What if the programmer simply writes the code like the way they did this in the past? Let me ask you this question. We did implement auto-closable at the top, so the compiler knows it. So I'm wondering, will the compiler give an error when this happens? I see a few people shaking their head already. No. All right, it at least gives you a warning. Would you agree? No, because you know this answer already, because deep down in your mind you know this. That is never to trust a feature with the word management in its name. So clearly that didn't really do anything good for us. So we are back to square one. If we really want to determine this cleanup, how do you do that? Well, here comes my favorite execute around method pattern. And this pattern has been around for a long time, several decades now, but we can make use of that in Java thanks to the Lambda expressions. So I'm going to go ahead and import java.util.function.consumer to begin with. And then now that I have brought in the consumer, what I'm going to do is let's get rid of this auto-closable thing. Let's go back and make the close method private really quickly. Now, obviously, if the programmer doesn't call the close method, they don't care about it. But I'm going to make the constructor private as well. And now the programmer is going to wonder what gives. How do I really create an object of this class? Now we have something in place. We're going to create a public method right here. And we will call this method as public static void use. And this takes a consumer of resource. We'll call it block for lack of better words. And we'll create a resource object is equal to new resource. As an author of the class, you can remember to do this, and you will, because the resource is important to you. And you say finally, and you say resource.close to really close it. Now that we have provided this little block of code, what we can then do is right in the middle of this, we can call the block and ask it to accept this particular resource for execution. So this becomes what is called the execute around method pattern. So the reason it's called the execute around method pattern is your code is going to execute on the line that's highlighted. But around that line, there's a pre-op and a post-op. The pre-op is where you construct the object and do other initializations you want to perform. And the post-op is where you perform validations and other things, including resource cleanup that you can do. So this becomes a nice kind of a sandwich where there's a pre-op and a post-op, and your code sits right in the middle. And that is exactly why some languages like Scala call this as a loan pattern. It's like rental car loan. When you go get it, hopefully they cleaned it up for you really well. And when you return it, they check for damages. So that becomes a loan, and they don't care where you drive around. So that's a loan pattern as well. But how do we use this particular pattern right here? We can go to the resource and say use. And within this use method, we'll pass a Lambda expression. And then within this, of course, we'll simply say resource.op1, and then we'll call the op2 right in there as well. So as a result, we are able to wrap that little block of code within the use. When we execute this code, on the other hand, we can see that the object is being cleaned up properly when you exit this piece of code. So that becomes a really nice way to create a lot of useful things in code. For example, I often use this when I need to perform certain policy enforcement. And I don't want to duplicate this code everywhere in my application. I don't want to also have programmers forget to perform these validation checks. So I wrap these things into a little execute around method pattern. And by the time the code enters that block of code, all the policies have been enforced and the checks and balances have been done. So, and then when they exit the piece of code, I can do a close-up operation and more validations as well. In an application I was working with, we wrapped our transactions into this boundary so that when we are given a transaction object, we can then return from our code, and based on the error code you return, the transaction is committed or rolled back, and proper logging is done. So we can enforce a lot of consistency. I have to say, hands down, this is probably one of my most favorite patterns in programming, and I've used this quite often in programming over the years, and I encourage you to dig a little deeper into it, looking into the execute around method pattern. Well, quickly to touch on this, I want to talk about traits in Scala. Now, I can't do justice to traits in Scala. It's a beautiful concept. I recommend you to Google for traits in general. But if you're really interested, I also have a talk separately for 90 minutes, which is called Traits, a Story of Traits. That's what I called it, just to talk about how beautiful traits are. But I'll mention a few highlights right here. Well, in Scala, you can create traits really quickly. So you can say trait, for example, friend, and you can create a friend, and you can define a listen, for example, as a method, which may take a name of the friend that you are interested in. And then you could simply say over here, print line, I am, and then you can say listening and stuff like that. Well, a trait compiles down to an interface in the case of Java. Well, if it's really compiling down to an interface, what's the big deal? I would say, look, your interface now has methods. And you may say, gosh, Venkat, have you seen this around? Java now has interfaces with default methods and static methods as well. All right, I give it to you. So that's exactly the question I had. This was exciting back in time, but Java now has default methods and interfaces. What gives? Well, traits still win in my mind because there's one thing traits can do that Java interfaces cannot do today, and that is called stackability. And stackability is where you can take multiple traits and you can stack them for a given object. So your object can have 2 or 3 traits, and when they do, they have what is called stackability. When you call a method on a trait, if the method is not handled, or even if it's handled, it can quietly forward it to the next object in the chain and the next in the chain until it can be handled by the object. And stackability gives us the power to create a certain feature. I grew up as a young programmer, programming in mainstream languages. And I remember painfully as a child, I was going to say child programmer, but not that much as a child, but as a young programmer, reading computer programming books. And I would hold these books in my hand, look through the window and say, my gosh, this looks so amazing. I really wish I could use this in the language I know or I program. And growing up as a programmer was reliving that experience in my mind, because all of a sudden, all those concepts I read about 30 years ago, I could suddenly use in the languages I use today, and that's been an aha moment for me. And the point I'm getting to is this beautiful feature in programming called mixins. Mixins really is kind of like going to Baskin Robbins or any of your other favorite ice cream store. You get this ice cream, and then you put toppings on it. That reminds me of my son. He has this unique capability of getting chocolate ice cream and putting chocolate mix-ins. I'll always look at him and say, who's your dad anyways? Kind of defies every logic. The point really is, ignoring that kind of behavior, mix-ins are really great. You can take a fundamental object and throw a lot of mix-ins on it, and even though it's a core object, you have a really enormous capability to extend the behavior. That's what traits give you. I won't go into the details here, unfortunately, but I encourage you to take a look at traits, because stackability and the ability to create mix-ins is an awesome capability. Having said that, I want to jump back to Java for a minute, because I again like what Java has done in Java 8 for a few interesting things. So to understand this, let's take a quick example. Let's say list of string names is equal to, let's create some names over here. So here are a bunch of names given to us, and the problem given to us is the following. Sometimes we talk about programming, and simple things should be simple, and complex things should be affordable. But unfortunately, sometimes that's not the way life is. Let's take a very simple problem. Print comma separated, let's say, names that are of length, let's say 5. And you look at this and say, gosh, that should be really easy to do. So how do we do that? For string name. Oh, that's a very easy way to start, a beautiful for each. And that comes from names, of course. And then what do? Print comma separated names, let's say in uppercase. Let's add a little bit more interesting feature to it, that are of length 5. So what am I going to do? Output the name. Well, you say, no, but I want only the names which are of length 5. So I could say name.length is equal to, and I'm going to say, in this case, the length is going to be equal to 5. If it is, then go ahead and print name.to uppercase, and then print it. So when you run this code, of course, the good news is it's printing the names in uppercase. But then you say, Venkat, there's this concept called requirements, and they didn't quite mean literally print them like this. It's got to be comma separated. Oh, darn it, of course, though comma, I can do it, and I'm going to put a little comma towards it. And then you say, yeah, but it's got to be on the same line. Oh, you know what, that's really not a problem. I can print it all on the same line. That shouldn't be a problem. But when you do it, then you notice there's a stupid comma in the end. Has anyone seen this problem before? Yeah, every one of us have done it. But the question is, how do you feel when that happened to you? You said to yourself, this is not happening to me, right? And then you sit there and you look at it and say, how do I get rid of the damn comma from the end? And then you're struggling with it, and then you tell yourselves, all kind of weird thoughts go to your mind, isn't it? Maybe I will strip it out of it. Oh, damn it, the string is immutable. Oh, maybe I'll use a string builder, you say. And somebody says, is a string builder or string buffer? Now you have an argument about string builder with a string buffer, then solving the real problem. And then as you're struggling with it, your colleague says, oh, come on, this is an easy problem. You shouldn't spend so much time on it. And you say, really, enlighten me. How do you do it? Oh, they say, all you have to do is this. Just go back here and say, if it's the last one, don't print the comma. How do you know it's the last one? Easy. Int I equal to 0, and then I less than. And 30 minutes later, we are debating about programming, isn't it? Now, this is an example of a simple code which is enormously complex in implementation. And imperative codes sometimes tend to have this. So what can we do to avoid this particular problem? Well, here's an example of how we could potentially solve it. We'll start out by saying names.stream, and I'm a huge fan of the stream API. We'll do a filter given a name. I'm going to say name.length is equal to 5, then perform a map operation, a string to uppercase, convert them to uppercase, and then I'm going to call the collect method. And for the collect method, I'm going to simply bring in over here the collectors API, the static method of the collectors. I have to admit, collectors is one of my most favorite Unity classes in the JDK. I love it so much that I was wondering what talks I want to give this year. I decided to give a talk exclusively on collectors later this week called Exploring Collectors, because it's packed with such wonderful features. But for now, what we're going to use here is joining, and I'm going to simply join them with comma separation. Honestly, this is how programming should be, isn't it? The day I learned about joining, I cried that night. That's the way it should really be, because it just removes all the burden from our shoulders, and we can write code like that. So that's an example of the functional style really shining, and we are able to benefit from this joining, and then we can join that with whatever we want to do. Could be a class path separator where it may make sense, and you can make really good use of it as well, and that becomes a nice little example for us to program with. So with that said, let's talk about one other interesting feature, and I'll show this in Scala, but I'll mention it in Kotlin for lack of time. But let's talk about laziness. Now, suppose we have a function called compute, and the compute function takes an integer, and I'm going to simply say called over here, and then I'm going to return an n times 2. And I have a x is equal to 4, and I say if x is greater than, let's say, 5, and the compute of, let's say, x is greater than 7, what do I really want to do here? I want to simply say print out the value is. I will simply say the value is, and we will call this compute and then pass the value of x to it. And otherwise, what am I going to do? I'm going to simply say else print line no value. So when I run the code, obviously it said no value. But is it going to call the compute method? And clearly you notice it is not calling the compute method. Why is that? Because we know this feature as short circuiting. Well, it turns out John McCarthy introduced short circuiting way back in time when Lisp was introduced, and every language worth its salt does short circuiting. Short circuiting is a tribal knowledge. Everybody knows about it. Moms feed their children telling them, when you grow up, be aware of short circuiting child, because not everything everything you see is going to execute when you run the program. So we know about short circuiting and the efficiency it creates. Good news, the function is not called when it's not needed. Bad news, when the function is needed, it's called twice in this example. What do we do about it? Oh, let's refactor it. Val temp, because temp is such a wonderful name, and we're going to say compute of x and simply replace this with temp and replace this with temp as well. Good news, we are not going to execute it twice anymore. It executes it once. Bad news, is the compute method going to be called now? What do you think? Yeah, it will be called. Why? Well, because it doesn't optimize the call here. What if the method were to have a side effect? You may say, wait a minute, the method already had a side effect. It did not call in the short circuit situation. Oh yeah, that is true. Why is that? That's called language specification. What is language specification? It means don't argue with the language. That's what it really means. Languages will make up the stuff and they will tell you that's how the language works. And languages don't call methods in short circuiting, but they may in other situations. But what if you say, don't bother calling it? Well, you can give a clue to the language saying lazy. So by saying lazy, as you can see, it bypasses the call until it no longer can be skipped. And of course, in this case, you can see that it did not call the compute. Without the word lazy, it called it. With the word lazy, it doesn't. On the other hand, when it does find a reason to call it, it calls it, but it only calls it once and caches the response. Now, clearly, you need to be careful about it. Lazy only makes sense when your functions are idempotent. If your function is going to give you different results for the same input over time, it doesn't make sense to use lazy, something you have to be a bit careful about. That's an example in Scala. Kotlin also has a lazy, but a completely different way of doing it by using what are called delegates. Well, talking about Kotlin, I want to share this one that I really like in Kotlin about argument matching. And I love these capabilities, and I have a good news for you. Java is going to have similar features between Java 12 and Java 14 with the introduction of the change to the switch and how that's going to become a nice pattern matching capability in the future. But now in Kotlin, let's take a look at an example. I can call a process function and pass a 1, call a process function and pass a hello. I can call process and pass a 15. Let's start with this really quickly. Now let's define a function called process. Now the way you define functions in Kotlin is by using this beautiful keyword called fun, because they want you to remember to have fun every time you write code. Sometimes we tend to forget that. So here is a fun, and I'm going to say input is any value that's coming in, and I'm going to simply say in this case, let's say in this case I say when, and what do I want to do with this when? I'm going to write it as an input. Now Kotlin when comes in different flavors. It comes as a statement, it comes as an expression, and you can use mix and match what may make sense to you. But in this case, what I want to do is simply say that if it's a 1, what do I want to do if it is really a 1? I'm going to simply print 1 over here. What if it is not a 1? I'm going to simply say whatever, just to say that it's whatever you want it to be. I really don't care about it. Now, as you can see, it says 1 and whatever. But then what you can do here is you can also say is a string, and then you can simply print out got a string, and you can process that as a string value that's coming in. So it says got a string. Or you can even go further and say, in 13 to 19, and I can say got a teen. So you can even process based on a list of values as well, and that becomes really elegant. So this can make the code really expressive and don't have to put a lot of effort into writing verbose code. It becomes really pleasant to write code like this. So that's an example of an argument matching in Kotlin, and you can make really good use of that when you program in languages like Kotlin. Again, by mixing and matching these languages, you can leverage these capabilities just like how we mix and match vehicles on a given day. Well, that brings me to one other really cool feature, and Java will have this feature eventually, but for now, let's talk about Kotlin. Well, if you were to do something like this, imagine this is Java code obviously, but in Java, let's say, we have a public static, let's say void process, which takes an object input. And what I want to do in this input is the following. I want to say over here, if input is an instance of string, then what do I want to do? I'm going to output the string let's say is of length, and then I'm going to say over here input.length. So question for you, will this work? No. Why not? Because length is not available on object. So what do you do in Java? You have to write this beautiful code. You have to first say string, but that's not enough. You have to wrap it around one more time like this, right? And then you would wrap these things around something like this, and then you can call the length method on it. Now, anyone remembers what this feature is called? Yeah, it's called casting. Well, they call it casting. I call it punishment. Well, the reason I call it punishment is, would you work with somebody who speaks like this? You ask them, is it a string? What's its length of what? Right? And that's what the compiler is doing. It pretends like nothing happened, right? And then what do? You roll your eyes and say, never mind, and you walk away. That's how you feel about it. Well, the code has to be intelligent. And I always ask this question when I program. Just pause and ask the question, do you work for the compiler, or does the compiler work for you? And it seems like sometimes we work for the compiler. It comes to you and says, more code now. And you're sitting and coding. And the compiler says, I'm going to go to lunch. You want me to get something for you while you code. And you're just sitting there and coding for no reason. Languages have to be smarter than that for us to be able to use it with pleasure. Well, let's take a look at what Kotlin provides for us. I say got a string, and I'm going to say of length, and I put a little dollar and say input.length right there. And when I run the code, you can see it was able to give us the length. Make no mistake, you cannot call length anywhere you want to call it. You cannot call length, for example, over here. If I try input.length, the compiler will ask me what am I trying to do, because length is not available on an object, so I cannot do that. That's an error. On the other hand, I can do it here because within this path, you and the compiler have agreed that it's a string, so you have asserted that, and the conversation has to carry over. This is called smart casting, and the good news is Java will do this eventually, and so we will have less verbosity in our code as well. But these things are really helpful to remove that kind of drudgery when writing code. Talking about that, we all love XML, isn't it? No, we want to write more XML, isn't it? No. Well, I've realized this over time. When you start using XML, you get excited. And then you program in XML for a week. Then you realize that coding XML should be given to people in the prison. Nobody in the free society should be ever forced to do it. Well, that is true to a great extent, but it doesn't have to be really that hard for us to use. So let's take a look at an example here. Let's create a languages over here. So I got a bunch of languages and their names and their authors. And I want to create an XML document out of it. How do you do it? Well, the very first step I recommend is never mention this to the boss. Tell the boss it's a very difficult work to do. And tell the boss it's going to take you 2 weeks to do. And then get this done in 5 minutes and take the time off after that. Enjoy in a nice beach. So here's a way to do this. We're going to create a builder. We'll call it as builder is equal to new groovy.xml.markup builder. So I created a builder. I say builder.languages. And when I run this code, notice how a little XML baby is going to pop out of this right away, because this is going to be simply a very small, a new groovy.xml.markup builder. And then I'm going to simply call the builder. Let me see what the error here is. So start back here. So this is going to be the languages I want to start with. Sorry, go ahead. Oh, did I do it in Scala? Good eyes, by the way. Awesome. Yeah, Scala doesn't like me writing groovy code. Thank you. So let's try this again. So run this. I love pair programming sessions like this. Can I take you with me home? This is amazing. Awesome. Thanks for your help. So right there is that's amazing eyes. You just absolutely amazed me. So that's basically the languages to be printed. What am I going to do? Define, let's say over here, a builder is equal to new groovy.xml builder.markupbuilder, and I'm going to simply say builder.languages. That's all I did. And notice, of course, when I run this code, a little XML baby just popped out right there. But of course, you say, but a minute ago it failed, because nothing ever goes right when you deal with XML and C++ in one place. But the point really is that this actually gave you that little output. But then I can say language right in there, and notice what this is going to do. It provides a child element out of it. Well, now you kind of get the picture. This is the DSL, a domain-specific language for creating a fluent syntax for creating XML. So in this case, what I want to do is simply say langs.each, and for every single language, I got a key and a value, and I'm going to simply print out right here the language inside that particular block. And as you can see, as many languages as I have, it prints those many of those child elements. But then I can say name is going to be an attribute with the value of the key, and then I can simply say author and provide the value out of it as well. I get to define a very easy syntax for creating that kind of an output, so you can pretty easily create an XML output and be done with it. So that becomes a nice way. To me, there are two benefits to doing something like this. One, you get to learn about how to do this, but I cannot tell you how many inspirations this has been, seeing this in languages, to go off and do this in other tools and other environments. We can go off to create our own fluent syntax and DSLs as well, and that can be really rewarding when you work with multiple different languages as well. So that is an example of how we can use the XML markup builder, and we can have these kinds of DSLs. Kotlin also has facilities to create with the type safety some of these capabilities as well. In Kotlin, of course, in this case, inspired by Groovy, and that's what I was talking about inspiration earlier. This can be really rewarding. A quick mention, you can use tail call optimization in languages like Scala and Kotlin. Well, this is not natively available on the JVM, but languages like Scala and Kotlin provide this capability by compiler support. And so if you really want to do recursion and it blows up on your face because of a call stack, you can pretty much deal with it pretty nicely. That's going to be really rewarding. But then I'll talk about another feature of Kotlin. This blew my mind because in the case of Groovy, which I'm a big fan of Groovy, you can do meta programming, but what if you can have meta programming with static typing capabilities, and Kotlin pushes the boundaries quite a bit towards that. So to understand this, let's take a look at an example. Suppose I write a function, let's say a greet, and I have a little string called greet. I'm going to simply say greet as a string. I want to print it. So I say over here, greet is equal to hello. Now, when I print this greet, you can see that it's actually printing the string. That's what it's going to print out right there. But then given this greet string, what I really want to do is to maybe have a convenience method added to this. So I'm going to say greet.shout. Now, obviously, if you meet a friend after a very long time, you're not going to whisper, you're going to shout. But unfortunately, shout is not a method in the JDK. I seriously think it should be, but it is not. But doesn't mean we have to take no for an answer. What we can do is we can go to the string class, and we can create a function called the shout function. And we can simply implement that to return a to uppercase as a result of this function call, if you will. So one of the nice things about Kotlin is it does these extension functions. Kotlin is full of extension functions in its library. Extension functions are beautiful because they really are not modifying the bytecode. Instead, extension functions really become static methods that are called using a beautiful syntax sugar. So you get the best of both worlds. You're not trying on the encapsulation boundaries. You're not modifying the bytecode. You got all the safety without compromising safety. You're able to get the convenience and elegance. That can lead to creating very fluent code as well. As an example, for instance, if I were to create a bit of a fluency, there's a lot more to this, but I'll show you an example. I have a pizza, but I'm going to create a spread function that takes a topping. Let's say we'll create this as a string, and I want to simply go ahead and say print line, we'll just say spread, so we can know it's being called. So I'm going to say pizza is equal to pizza, we'll create an object. I say pizza.spread, and we will go ahead and ask it to spread some cheese over here, and maybe let's go ahead and put some olives on it. So we can write code like this and get it to work, but wouldn't it be really nice, ignore the warning for a minute, wouldn't it be nice if we can actually be able to call it very fluently? Just to entertain the thought of fluency really quickly, I remove this dot, I remove this parenthesis from here and here as well. But for us to make this work, there's a little bit of a clue the compiler gives us called the infix. So we can mark this method as infix, if you will. And once you mark a method as infix, what it provides for you is the ability to write a very fluent code. So this paves the way for creating BSLs in your code to create fluency as well. And that can be really charming. So you can create infix functions and remove the noise in the code. And you can push this boundary to create code that looks extremely dynamic, but you're able to enjoy all of that in the case of a static type language. I got a deepest respect for pushing the boundaries that way, and we can benefit. So in the time we had with us, I hope I gave you some things to really ponder about. Fluency, we can create convenient code, less noisy code, and of course, easier to implement certain features. If you're interested in downloading the code examples I showed you here, you can point your browsers towards the download page. I hope that was useful. Thanks for coming.